manufacturers face urgent challenges to be net zero, resilient and technologically advanced. But those challenges are opportunities for companies that innovate.
The good news is technologies like AI, ML, cloud, blockchain, big data are maturing, and companies who have adopted are seeing early success in achieving their sustainability goals.
Increasing the use of simulation and virtual methods not only improves sustainability, but also shortens the product development cycle.
The need for innovation to increase productivity, improve ecological impact, and become sustainable is the biggest it has ever been.
Righty-ho, Graeme, kick us off. What's the picture, the kind of big picture, first of all, right across the sector when it comes to sustainability?
So I work for HORIBA MIRA, and we're an engineering and testing consultancy business supporting OEMs and tier ones internationally as well as in the UK. And one of the things that we're seeing a lot now, our customers previously have really been focused on speed and flexibility. So it was interesting to hear Michael talking before about 4 years development time. We do a lot of work with startup companies, and everyone is pretty consistently pushing towards 2-year development cycle, which improves sustainability, but it's very much about speed to market and getting the products out there quickly. But increasingly, people are much more interested in the sustainability of the whole development cycle. So we're very active across all of what we're doing. We've got an 850-acre site, so a proving ground with 100 kilometers of test tracks and very extensive facilities. And there's no one silver bullet, and it was great to see some of the examples that Richard had earlier from Toyota about the multitude of things that they were doing. And we're similarly having to address a whole range of different areas to improve sustainability across all of the activities that we have, from existing solar power generation, green electricity tariffs, and investing in further solar power generation to power the suite of facilities that we have, as well as the development vehicles of which we can charge up to 100 electric vehicles at the same time across the site. And we're also using some of that green electricity to generate hydrogen on site with an electrolyzer coming on board soon. So again, tying into what Chris from Alexander Dennis was talking about and some of the other the panelists about hydrogen for particularly commercial vehicle applications, because the availability of hydrogen for the commercial vehicles and for testing and development is a big challenge. So we've got currently the ability to refuel vehicles at 350 bar, and in about a month's time also 700 bar, to be able to accelerate the development of hydrogen vehicles as well as EVs.
It's interesting how much of what the kind of aim, the sustainability aim, is obviously driven by what is technologically possible at any one time, and what will become possible in the near future. Yeah, absolutely. We have to look across the entire development chain for the vehicles. So there's a lot of talk earlier about taking out carbon from the manufacturing of the components, the vehicle assembly, but the impact of the product development is becoming increasingly important. So everyone has a part to play in how we can improve that whole life cycle for the vehicle. And Tim, when you look at the gains, are they in manufacturing? Are they in vehicle technology? And are they in both?
So the gains are across the entire sector. It's not just in one manufacturing. It's not just in automotive. These kind of technologies which we've been talking about, whether they be the kind of things that we see at MIRA in terms of the physical testing, or whether we look at digital technologies as well, they can be applied at every stage of the manufacturing chain, all the way from design processes, where we can use digital technologies to provide further insights into what customers want from their vehicles, how they're using it, what gripes they're having with them, all the way up to the engineering and the aftercare of it. So across the whole sector.
Yeah. And when you're looking at the individual areas, the pieces of innovation that ought to be concentrated on, the kind of innovation areas that ought to be concentrated on in order to make this stuff happen, because you look right around the world, what are the places that seem to be likely to work?
Yeah, so, excuse me. We work with many manufacturers, hundreds of manufacturers worldwide. And as part of my role in TCS, I head Sustainable Manufacturing Unit. So what we are seeing, 3 areas I find it in the focus for innovation. One is on circularity, which we all heard this morning. Now, a little bit delve deeper into what is that circularity and where is the focus, especially in that circularity would be. In the 80s, we all heard about MRP, and the technology helped in MRP, which is materials requirements planning. Okay. And then in 90s, the MRP expanded into manufacturing resource planning. It is not just about materials, it's manufacturing resources put together. So it is manufacturing resource planning. Again, it is MRP, so we added MRP2 there. And then in the late 90s and early 2000s, this further expanded. The technology helped. To your point, Justin, it's a cyclical thing. The technology helped, and then we said manufacturing resource planning. Yeah, we need to expand it to make it enterprise-wide. So we got into enterprise-wide resource planning, ERP. So SAP's, Oracle's, some of those big players in that space. Today, with the focus on sustainability, it is not just an enterprise-wide play. It's an ecosystem-wide play. So I think how MRP2, then ERP, now it's time for innovation in ERP2, which is ecosystem-wide resource planning. The panel before spoke a lot about ecosystem. So a lot of focus on technologies to bring the ecosystem-wide players to create the circular economy. More, we can discuss about that. The second area of innovation is keeping customer in the centric. We spoke a lot in the previous panels and in the keynote about customer experience, especially in the charging area. Again, charging ecosystem is a multitude of players need to come together, right from finding a charging point or a charging place to seamless payments to various other players. The third area, which is often is underrated, is the ways of working on innovation. So we advocate adopting the agile ways of working, which is fail fast and then take small programs and projects and do a faster innovation in those areas. So those are the 3 areas: circularity, customer experience, and in the agile ways of working would be the focus of innovation.
Okay, so Paul, take us to Britain. Focus on the UK and focus on what needs to happen.
So thank you very much. So I'm Paul Gadd from Innovate UK. We've previously launched our transport vision, which lays out what we think is going to happen with the powertrains on vehicles. But we've also this year launched our manufacturing materials vision, because as we've heard, it's not just the tailpipe emissions, it's the manufacturing. And actually that's the really tricky bit in my opinion. So it's actually been a couple of years of work. We've reviewed 200 documents, spoken to 200 stakeholders before we've published this document earlier this year. And we've focused in on 3 strategic priorities: net zero and resource efficient, resilient and responsive, and technologically advanced and digital. And we think that companies that are successful in those strategic priorities, they're the ones that are going to succeed in the future. So if you focus on those outcomes, you can then identify, well, if that's true in 2050, what needs to be true, what needs to have happened in order to make that true? So you can then trace back through some innovation pathways and say, well, these are the key areas of change where change is needed, and therefore there's opportunity and also risk to companies. So we've published this, we've shared it. It's a lot of work, and there's 3 reasons for sharing it. One, it's going to explain why we're going to do what we're going to do. So as Innovate UK, we invest around £2 billion a year of public money. Not all our own, some DFT, some Department for Business, etc. But we do invest in the manufacturing space. And this will guide our investments and explain what we're trying to do and why we're trying to do it. The second reason to publish it is because we think it's quite a useful resource. If you're looking at your manufacturing strategy going forward, there's a lot of work gone into it, and it might be a useful input to you for some of your decisions. And thirdly, because it's a look at the future, it's probably wrong. So we're inviting your feedback. Tell us where we're wrong, and we'll correct it, because you'll course correct us, and you'll perhaps course correct some other people. And if I may, there are 3 really important things that we've taken as our headlines from doing this work. One is that manufacturing materials is absolutely mission critical for the UK in terms of our society and our economy. It's a really, really important area. 2, it's a really stimulating and exciting area to work in. There's a huge amount of change, and genuinely, the people in this room and in our manufacturing communities are going to change the world, and that's a pretty cool thing to do. And the last thing is it's a really difficult challenge because it's quite a compressed timeline to make all these changes, but it's doable, and it requires the best talent, and it very much links back to the skills talk that's been, and various things that have been talked about through the day. But the first 2 things, the fact that it's such an exciting mission and critical for the UK, perhaps that helps us draw in that talent that we need.
Yeah. And then how do we bring the sectors together to do the work that needs to be done?
Yeah, so since I spoke about the ecosystem right here, so one of the key ways to bring different parties together, let's take for example, recycling of battery, right? We spoke a lot about the battery today morning, and then it's important to bring the battery back into the life cycle. So if we look at this, there are a lot of different players. The battery goes into the EVs and then goes to storage, and then from there different applications, and then it has to come back to the OEMs have the responsibility to bring it back and then recycle the batteries. So there are multiple players along this value chain. So if we take the value chain view of it, like Ram, you said before, in terms of not just the manufacturing, but if we take the value chain view of it, what we are trying to do, bring together is different companies together. For example, a steel company would be interested in recycling the steel, the batteries, etc. So technology like cloud and the platform gives a great platform for these companies to onboard and do the transactions. What are the transactions here that we are talking? Sourcing the recycled parts, reprocessing them, renewing them, remanufacturing them, and then selling it online or selling it to their things so that the recyclability and the renewal of this increases. So to get a true circular economy, it is imperative that we bring all the ecosystem players together, and technologies like cloud gives a platform for all of them to onboard to that common platform to be able to see through the supply chain across the value chain.
Yeah, it's interesting, Graeme, isn't it? We tend to think about electrification, but there is much more, isn't there, going on? There are many more avenues to go down.
Yeah, absolutely. So while there's a lot of talk about electric motors and batteries, and we do a lot of work with batteries, we've got the most comprehensive range of battery test and validation facilities in the UK. But there's another couple of areas that are worth mentioning where there's gains to be had. So one's related to ADAS systems, so assisted driving all the way through to autonomy. And there's potential benefits there related to the efficiency of the driving, but also the safety. So it's driver convenience, but it's also safety, and that feeds into traffic flow, for example, traffic management, preventing accidents. So last year, there was around 30,000 people were killed or seriously injured in road traffic accidents in the UK. So obviously there's all the downstream impact of the healthcare and the support for them, let alone the disruption to the actual traffic flow and the impact of that. So there's safety and sustainability are quite closely interlinked. And this is an area where we've been very active in our investment in a suite of facilities, a wide ecosystem called AssuredCav for validating and testing assisted and automated vehicles in order to make sure that they are safer and that they perform better when they do hit the road, so that the users actually adopt them. Because one of the complaints that we know that the end consumer has about some of the ADAS features is that they interrupt the feel of driving. So it's about how natural it is, and that's really to get the user adoption and acceptance. And the other area worth mentioning is the thermal energy management within the vehicle. So around 25% up to potentially 60% in extreme climates of the energy within the battery is used for thermal management of the occupants of the vehicle as well as the battery itself. And so that's really the next battleground we feel for improving the range of vehicles and There's work that can be done there, and we've developed our own tools and capabilities and facilities to support that, around looking at the human comfort modeling rather than looking at vent temperatures for air. How does the human feel? So things like using seat heating, steering wheel heating, the use of reflective glazing in order to reduce the solar loads on vehicles. So these can extend the range by several percent or allow cost reduction for the vehicles, so to achieve the same overall range. So there's lots to go after beyond small incremental gains on battery technology or on electric motor technology.
And of course, Tim, the background to all of this, the digital revolution, the digital technologies that are available to drive it.
Well, yeah, exactly. There's, in terms of where we're looking at in terms of the digital technologies which are on the road now already, they're already out there, improving on the fuel efficiency, improving on the ADAS system, as we've heard, improving on that comfort and sustainability. But really what's key in terms of looking forward and going forward for the further adoption of these is for companies to not be afraid to adopt the next generation worth of technology. So, you know, talking about artificial intelligence and likes of quantum computing, they've got real possibilities to help with sustainability, to drive the performance, the optimization of this next generation of vehicles, which we're going to be seeing coming onto the roads.
Give us an AI example. What is around the corner when it comes to the application of AI, the use of AI in this area?
So when most people hear about AI in automotive, they jump straight to self-driving vehicles or autonomous vehicles. And although they are important and there's worth having conversations around, I want to steer people's focus away from that and more onto where AI can be applied at other areas within the manufacturing and design phase. So you can use AI algorithms to help design more efficient, lighter vehicles through generative design of creating your parts. You can use it to inform on the internal systems around kind of energy management, energy transfer. You can use it to speed up your simulations, your modeling, which you might be doing for aerodynamics if we're talking about kind of your high-end sports cars, or even potentially the fluid flow as it goes through a vehicle. So talking about thermal management there. All of these areas are ways in which you can apply these cutting-edge technologies such as artificial intelligence, quantum computing, supercomputing, the likes, in which they aren't necessarily so glitz and glamour. They don't hit the headlines, but they are ready right now to be providing real-world solutions.
And when you say they don't hit the headlines, I mean, one of the things about AI that hits the headlines again and again is the kind of ethical considerations of it. Are there such considerations that people have to think about in this area?
So there's definitely ethical implications which people need to consider when looking at artificial intelligence. It's a new phase of technology, one where, you know, we have computers which are starting to think for themselves. But when looking at the application areas for it, I don't think there are the same ethical considerations which are being talked about within the news that the public have picked up and run with. You know, the likes around ChatGPT and whether the results you're getting from that are accurate or not. Whereas what AI should really be considered as within automotive industry and in lots of the other sectors within the UK is it's more just another additional tool within the toolkit. You saw you know, a lot of similar issues with other technologies in the past. So one great example is robotics and robotic cells and manufacturing lines. When that first came out, there's a lot of news articles around how they'll cause more injuries and then they take away jobs and various different situations like that. But now it's the norm to see a robotic cell on a manufacturing line. And you don't have a untrained person operating that robotic cell or heavy machinery. Just like when you're applying AI into your process, your products, whatever it is, you shouldn't be doing it without proper training, proper regulatory support, and proper codes of conduct.
Just a final thought on AI. I mean, in other areas, the initial thought has been it's going to take away jobs, and then in the longer term, all these innovation things actually lead to probably more jobs in the long term. Is that going to be the picture?
Yeah, exactly. We've seen that model play out time and time again. initially, there may be some things which it replaces. But I come back to, it's another tool for your toolbox. It will be something which can aid the skilled engineers.
Yeah.
It can take away from some of the mundane tasks which just people, when they get nearer to the end of a shift, naturally we start to miss out on. You know, talk about computer vision on manufacturing line, for example, using AI to spot defects there, or within paint adhesion or welding. As a person gets tired and fatigued, they will be missing out on that, then that causes additional work down the line. Whereas if we can utilize an AI in combination with a skilled engineer, in combination with someone who is able to apply what they are seeing coming out of artificial intelligence, then you can just increase the productivity. You can enable more time for the skilled engineer to do the thing that they are skilled in.
Yeah. They're always talking about replacing journalists with AI, which of course would be unethical and is an outrage and mustn't happen. So some people say, as we have to say in the BBC. But where does the money come from for all of this stuff?
Well, let's say we've got a significant amount of money flowing through us from both the UKRI Central, so we're both part of UKRI. I'm part of Innovate UK, we're the industry-facing in theory bit, but obviously...
Yeah, and I'm part of the Science Technology Facilities Council, more specifically the digital technology side of that, supercomputing, artificial intelligence, quantum computing. We've got this, the scientists and the researchers on site who are experts within this.
But lots of funding, as I mentioned earlier, £2 billion flowing through this year and for the number of years. So some programs that people will be familiar with the APC, CCAV came up, and the CAV Fourth project, that's part government funded. There's really significant DFT programs in 44-ton HGVs and trying to understand battery electric versus hydrogen and what works where. £200 million in Maritime, £20 million in hydrogen demand. The Faraday Battery Challenge at £541 million, £80 million for driving the electric revolution. And they bring things like the UK Battery Industrialisation Centre and the Driving the Electric Revolution Industrialisation Centres as well. Made Smarter, the challenge there, £147 million. Make and Use Net Zero, which links directly back to the vision. And one of the really big ones in terms of manufacturing is the catapult network. So we've got the high value manufacturing catapult network in the room. There's £800 million of core grant that goes into that network just into the high value manufacturing catapult over 5 years. And then they do collaborative work, and they also do commercial work, which actually triples that budget over that time. So a massive 2.4 billion over 5 years. And that's one catapult. There's then a number of other catapults out there providing tools, resources, expertise.
And what about other areas of innovation, other sectors that might be involved? I mean, the obvious one is energy, I suppose, isn't it? What about the link up there?
Yeah, so we have an energy systems catapult who, again, can help people with that. You're right, there's lots of crossover, and I think a lot of the reason to put public money in there is along the theme of this conference, is about collaboration. So it's to share the risk of collaborating. It's unlikely that one organisation is going to have all the skills for a breakthrough innovation, and actually the really exciting bits are around the edges, so between transport and energy, or between transport and AI. And those sorts of programmes like Bridge AI, which has been launched, £100 million to try and help AI be adopted into a number of sectors, with transport being pulled out as one of the 4 key ones. That's a real opportunity to go and try some things with some government support, and we'll share that risk with you and help you go further.
Yeah. Of course, all of this has to be measured, Anandh, and how good are we at measuring it, particularly across sectors, as it were?
Yeah.
The gains that are made.
Absolutely, because you can't improve what you can't measure, right? So we, in this industry, manufacturing and automotive, pioneered the concept of Six Sigma Lean, which is underpinned in terms of the data, the measurement. So if we apply that, okay, we have the define, measure, analyze, improve, and control DMIC. So define the sustainability targets and KPIs is relatively easy because we have frameworks, SDBA targets, government regulations, SDG, and so on. However, the first thing, this very next thing after that is the measure. So how do we measure the data? For example, even the baselining the energy consumptions and doing the improvement on that across different manufacturing plants, because we, in this industry, we grew by acquisitions, we grew in different plants in different places with different networks, systems, etc. So the first thing is to invest in vendor agnostic sensor data acquisition and management, DAM systems. So this will even out the discrepancies in data across plants. And then because I have seen in many companies, their KPIs itself are measured differently in different places. So this, it's all common thing that you will see hundreds of Excel spreadsheets going. So the important thing is to iron out those differences in the data collection part of it, and then apply the statistical techniques with the advanced technologies like AI, ML to do the rest of the thing, which is analyze, improve, and control. So the fundamental thing is to get the data in an harmonized way with the relevant, with the right frequency, and with the right recency to be able to get to the right analysis. Else we are missing the trick here in terms of what are we going to improve, and what's the baseline. Many companies struggle to even get the baseline right when it comes to the achieving the targets, the net zero targets, for example, in 2030 or 2039 and beyond.
We've mentioned, a couple of you have mentioned high performance computing, quantum computing, the use of big data, the kind of high-end tech stuff, if I can put it like that. Tim, to what extent is that currently driving what's going on? Are those kind of new technologies, those frontier technologies being used?
So there's a lot of opportunity within the automotive and transport sector at the moment for these technologies to be applied. As Paul mentioned, there's the Bridge AI funding out, which is directing specifically at transport as one of the 4 sectors it's aiming at, because it's been identified as a sector which is lagging behind the rest of the UK in the adoption of these advanced technologies. Whereas in terms of where the sector should be, is it should be leading it. With the current kind of move towards electrification and alternative fuel sources, so as in towards net zero, we really need to look at harnessing the digital technologies in order to provide that innovation which is required to do this quite sharp turn in the road of what the automotive sector looks like.
Yeah, but I mean, it's a sharp turn in the road, but I'm thinking, for instance, quantum computing. I don't know, maybe everyone here is an expert in quantum computing. I'm just thinking how actually, if you're running something, how does that impact on you now? What should you be doing in order to prepare yourself for a time when quantum computing is more prevalent than it is?
Yeah, so quantum computing is an excellent example of that, because it is something which we've got quite good understanding of, but we're not there yet at scale of where it can be applied across a sector. However, we are rapidly increasing within what is possible. 5 years ago, no one had heard of quantum computing. It was kind of more something of science fiction or of pure academic research. Whereas now we're seeing more and more companies who are actually putting funding and investment into how they can utilize quantum computing when it comes along. We're not far off. 5 years ago, when we first started talking about quantum computing, we'd say 5 to 10 years. Now I'm still saying 5 to 10 years, as ever with these technologies. But you can now access a quantum computer utilizing cloud infrastructure. So you can build that within your workflow. You've got compute infrastructure from the likes of Atos with the quantum learning machine, which is a classical computer, but it simulates what a quantum computer would look like, so that you can start to develop the algorithms now. So I guess my advice to the sector is to start looking at how you can apply it now. Start talking to the experts, because it's going to come, and when it comes, automotive needs to be leading in the application of it.
Can I add?
Yeah, do.
We have
final thought, I think this is going to be.
We have a quantum challenge. We have a quantum community out there. We've got some really good UK companies. As with anything, any area that you're interested in, we will have a community that we can link you into, make connections, help build some understanding, because quantum computing, I'm not an expert in it, but as far as I can tell, it's going to make a right mess of our online security, and we'll need to do quite a lot of activity to sort that out. But the good news is we do know about quantum. We do have some good companies. We're very good at cybersecurity. So
it kind of also goes, doesn't it, to this point we were making, several people make earlier on, is whether this industry, writ large, or all bits of it, are now that with with a tech side to them, or whether actually you're all tech companies, really, in the modern era?
I'd argue that as we're moving towards it, we are going to be technology companies which deliver mobility. And whether that mobility be private vehicles or whether that be within public transport or trucks, it's going to be technology driven, and that's the way we need to go.
Yeah, so interestingly, I was working in the automotive sector before I joined the digital software company TCS. So here we talk about the software. Business, when I joined about 14 years ago, we had this big divide between IT, software, and then the business, and then the business, whether it is supply chain, engineering, or manufacturing, would decide something that needs to be done, and then it will come to the IT. No, that's not the right way to do this, because what I now realize is, interestingly, there is more software in the car than what I had in the automotive.
Yeah, okay.
So therefore, the business leaders, all in this room and beyond, should embrace and imbibe the digital technologies, having an understanding of it,
right,
and then bridge the gap between the digital and the business. Yeah.
That has been the message right throughout the day. We've got to leave it there, though. That's a fascinating panel. Thank you so much, all of you, and give them a round of applause while they leave the stage.